Okay, so I'm going to go ahead and finish up the tangent line part of the notes today that we didn't get to. All right, tangent lines are very important because they're a method of approximation. Once you realize, so if we have a curve, we do a tangent line. So this assumes we know this point, but we are extending this graph out and saying, well, this point estimates this. There is an error, but it's really, we don't always know what the curve is, but at least we can use the data. We write a tangent line here and we can use it later. So I'm going to show you how to write the tangent line. So I want to remind you, we need three things. We need an x, which we have. We need a y value, which in this case is 8 times pi over 6 times the sine of pi over 6. So that's 4 pi over 3, and the sine of pi over 6 as the y value is 1/2. So that's 2 pi over 3. So we know the x, we know the y, now we got to find the slope. Well, so that means I got to find y prime, or dy dx, same thing. And we have a product here. So we have to use a product rule, which remember is the derivative of the first one, which is 8, times the second one, which is just the sine of x. So it's the derivative of the first one times the second, plus the first, which is 8x, times the derivative of the second one, which is the cosine of x. Okay, so we did the, so if this was u and v, this was u prime times v plus u times v prime, or the derivative of the first times the second plus the first times the derivative of the second. All right, so now we're going to need to find y prime at pi over 6. So it's 8 times the sine of pi over 6 plus 8 times pi over 6 times the cosine of pi over 6. Okay, so this was 8. We found the sine of pi over 6 was 1/2. Plus, that's 4 pi over 3. Well, the cosine of pi over 6 is the y value. Well, if this is 1/2, this is root 3 over 2. So that's the x part of it. So this becomes 4 plus 2 root 3 over 3. And that's our slope. Okay, so we have our point, x, a y, and the slope. So we're going to write it in point slope form, no simplifying. So it's y minus 2 pi over 3. Y minus y1 is equal to m times x minus x1 is equal to 4 plus 2 root 3 over 3, and since that whole thing is the slope, I need to put it in the parentheses, times x minus pi over 6. Okay. A lot of times the derivative won't be this complex, but at least I wanted to do one involving the chain rule. Or excuse me, not chain rule, but the product rule. Okay, so now we're going to do one of the tangent line, then normal. By the way, normal is just perpendicular. So once we know this slope, we can easily find out. Okay, so at 3, we need to find g of 3, which is 4 times the square root of 15 plus 1, which is 16. Square root of 16 is 4, so it's 4 times 4 is 16. Okay, so we got a y value. Okay, now we got to go find g prime. Well, want you remember this is 4 times 5x plus 1 to the 1/2 power. This one we're going to need the chain rule. So if you didn't get to the chain rule stuff, this might be a little bit tricky for you. Okay, so if I know that g of x is 4 times 5x plus 1 to the 1/2 power, we got to do g prime of x then. So it's bring along the 4. We first take care of the power. So it's 1/2 times 5x plus 1, and I lower the power by 1 unit. So it becomes negative 1/2. Okay, so I took care of the power. We don't have a function like a sine or a cosine here, so now I have to go differentiate the argument, which is 5. Okay, so and that's our derivative because I took the power first, kept the argument the same, and then differentiated the argument. Okay, so this is 2, makes that 10, right? So it's 10, and this is really on the bottom, the square root of 5x plus 1. So that is our derivative. So what I'm going to go plug in there now is 3. So g prime at 3 is going to be 10 over the square root of 15 plus 1, which is 16. Square root of 16 is 4. So it's 10 over 4, or 5 halves. Okay? So I know all my pieces. I know the x, I know the y, and I know the slope. So it's going to be y minus 16 is equal to 5 halves times x minus 3. And I don't simplify it at all. Okay? All right, compute the slope, or the point and the slope. All right, normal line just simply means perpendicular. So the slope we're going to use for this, remember, is the opposite reciprocal, which is negative 2/5. Okay, so it's going to be the same point. So it's y minus 16 is equal to negative 2/5 times x minus 3. So if we had a curve for the first one, where we square root function is going to look like this. And this is at 3, we do a tangent line, was that? And the normal, so this was tangent, and this is normal, just means perpendicular. Okay? All right, hope this helps. Hopefully you knew your derivatives. If not, we got work to do on product rule and chain rule. Okay? Thank you all. Bye-bye.